All right, so we're back, and we're COMP123. It's lesson 1, part 3, and now we're going to get into this review for at least another 20 minutes, and I'll let you guys go a little early, because I know you guys want to run to your next class because it's so important for you to be there on time, right? I'm being facetious. But anyways, so I'm not going to run all the way to the end of the class today because I think I've done most of the things that I wanted to do. I just want to go over some of the lessons that we did or that you would have done in Comp 100. So let's look at lesson 1. And in lesson 1, and I'm not sure if you guys were given PowerPoint presentations, I'm guessing not. Right? Not? I will have them. I will post them all. Right? So you'll have all the PowerPoint presentations for the entire book. That's what I do. Right? Some of them will come up in spits and spurts because it's just the way it is. But I'll post them eventually. They'll be all in PDF format, so if you don't have PowerPoint, it's okay. And let's see if you can actually see this one. Like that. Hold on a second. All right, maybe I would make it bigger, but I'm afraid that part of it's going to be cut off for you guys to see here physically in class. However, if I was to, I know that it's been recording everything, my entire screen, so actually on the YouTube, you get a better experience than you do here, right? So I will be putting it up. Oh, so they did give it to you. Okay. So this is right from it. I've added a couple things, and I will continue to add a couple things, to the presentations, only because I want to make sure that if there's content that's missing, I want to kind of hit it, right? So again, we talked about, you would have learned a little bit about programming, and we talked about a little bit about object-oriented programming, and some stuff around what software and hardware, machine language, the difference between a high-level language and a compiler, some programming logic, and what the difference is when you make a logical error as opposed to a syntax error. What's the difference? Logic error, syntax error. Yes, Smarty. I'm going to call you Smarty from now on because you're answering all the time. Go ahead, Smarty, go ahead.
Syntax error is when the code structure doesn't match the one defined for the programming language.
Holy cow, dictionary definition. And then?
And the logical error is when the user wants to do something else, but the output is different because of his wrong logic.
So wrong logic causes an error,
For example,
right?
he wants to add something, but he puts a subtraction sign
Instead of an
wrong,
add sign.
so that's what.
Very good, very good. What about a systematic error? Anyone ever hear of that? Systematic error. So it's an error that I'm making, but I'm making it systematically. It's like a logic error, but it's not just an error in thinking. It's an error in how I'm doing things, right? Can that also be a group of errors that can you get errors from there as well? And I'm not talking about errors as in syntax errors or errored output. I'm talking about errors in the way you program. Is that possible? Would you agree? Right? A systematic error. So sometimes there's those types of errors as well. And I want to try over the course of the next 15 weeks to get around that. Right? So we're going to do some diagrams. We're going to talk about these kind of things. You should have done pseudocode a little bit in first half. Right? So programming 1. Right? Did you? Is that no? I'm seeing some people go, no. I see other people, yeah, I did some pseudocode, right? So we're going to talk about a little bit of pseudocode. So some of your assignments may require you to do a little bit of an external document that says, I want to outline my code that I'm doing with pseudocode, right? It's not just about programming, because here I want you to get some understanding, right? So part of what I'm going to be asking before from an external document perspective is show me, right, how this is working in plain English, pseudocode, so to speak, right? Input, kind of like that IPO idea that that Narendra, the other professor, I don't know who had Professor Narendra last time. All right, so probably most of you had him. So he uses his IPO way of doing things, input, kind of processing and output. I like that in some sense, right? So you have this algorithm, which is the processing piece. I want you to define the algorithm for me a little bit more in your plain English, plain words, right? So when we think about more complicated algorithms, especially as we move into things like object-oriented programming, right? I want you to think about, okay, here's my algorithm. How should it work? What am I looking for? What are the pieces of procedural code that I need in here? How about methodology? How do I do that? And I'm gonna ask you to do that with pseudocode.
What's the difference between pseudocode
And
and algorithm?
an algorithm? Well, your algorithm can either be physically programmed in the machine or it can be seen on pseudocode. So you're showing your algorithm almost like here's my step by step, But pseudocode actually isn't the algorithm. It's just showing your step by step, right? So yeah, this is how the processing works. And some people might say, well, that's the algorithm. But really, the algorithm is when it's finally written. And it's going to be a runnable and executable algorithm that you can put on the computer. That's why I define it. Debugging. So part of a good programmer is debugging. I'm going to present you you might get an assignment that's full of errors, right? Or it might be your exam is going to be full of errors. Do you ever get that before? Here's the errors, fix it. That might be the way I do some assignments as well. Here's the errors, fix them, kind of thing. Because a lot of times in the real world, and so I'm relating to the real world for you guys, right? When you guys go and become programmers, you're not going to write your own code, eh? It doesn't happen very often, especially on the software programming side. You're going to be revising and reviewing other people's code, right? Maybe there's going to be somewhere, it's going to be done offshore. So there's going to be some offshoring done. Maybe it's going to be India, because we do a lot of stuff, especially in the industry. Like I know when I worked for RBC and for Bell, right, we did a lot of offshoring in India, right? So the Indian programmers, very, very, they know how to do things. Sometimes they don't go through the program requirements as we need to. So we go to do a program review, and I have to look at their code, and it's full of errors. Logical errors, not syntax errors, right? Because what I want from a requirements perspective and what I'm getting from an output doesn't match, right? So that's part of our unit testing stuff that we would do. And so you're going to look at that stuff. So debugging is a really important piece of it. So one of the assignments I might give you is fix the problem, right? You might get one of those. You might even see it on the exam a little bit. Here's this little piece of code, it's broken, fix it, right? And it might be some silly, error like there might be some semicolons missing, that causes a syntax error. And I want you to do it by eye. I don't want you to do it by programming. So it'd be one of those, right? And we'll do a little bit of that as we do these online kind of polls too, right? Okay, so we talked about object-oriented programming a little bit. Some people also use camel casing and Pascal casing when they do their programming. Was it enforced for you guys last time for programming one? When it comes to making variable names, did Professor Narendra, did he enforce the camel casing and Pascal casing? Some people say yes, some people say no. Right? I'm going to enforce it, guys. I want good, solid variables this time around. So I don't want you to use X's and Y's and I's and B's and C's, right? Unless it makes sense. I want the code to document itself. One of the requirements you're going to have for your assignments is document your darn code, right? Which means put in your comments. If I don't see comments inside your code, I don't know what it means. And again, one of your roles may not even be programming in the future. When you leave Centennial, maybe you're not going to be a programmer. Maybe you're going to end up being a manager, right? So you're going to look at people's code and you're going to go, what the hell is this, right? Because do programmers document their code? The answer is largely no. It's a bad thing, right? So you're going to pick up somebody else's ugly code and you're going to look at it and you're going to go, what the hell does this do, right? I don't want that to be you. I don't want you to be the ugly programmer. I want you to be the beautiful programmer with nice code and good documentation. So in order for us to get there, one of the requirements is going to be good documentation. And I'm going to be asking for camel casing, lower casing when it comes to things like method names and properties, and upper camel casing or Pascal casing for class names, right? So they have to make sense. Like it's pretty simple. And also the name should make sense. Like if you're doing a for loop and if I go for I is equal to, please don't use I. Please use something that, what are you counting with the for loop? Use count, a counter, a number, something that makes sense. And if it doesn't make sense when I look at the code, document it. So what I mean by that is put a comment in, a single line, like a line comment that says, hey, from a for loop perspective, this for loop is iterating across this thing to produce this output, whatever that code is. So your output's really important because I look at your output as a final result. But equally important for me is your internal documentation and a little bit of external documentation. Okay, so keep that in mind when we do our assignments. So, and if you have a question around that, well, we can talk afterwards. Like, what does he mean when it comes to the internal documentation? Well, when you get your first assignment, you'll see what I'm talking about. Right? And by the way, on the internal documentation side, on the external documentation side, it gives you an opportunity to get a few more marks. Let's say you're not a great programmer. That's okay. This is only your second course for some of you, right? So that means you don't have to be a great programmer yet, but I want to make you a great programmer by the time we're done programming 2, because programming 3, you need to know what you're doing, right? Then you're going to be in trouble. Actually, I want you to go into programming 3 and go, wow, programming 2 is kind of difficult. Programming 3 is easy, right? I'm not saying I'm going to be difficult. I'm just saying I'm going to challenge you, right? So when I do that, bear with me. I'm not trying to be too hard, but I'm going to require that you follow along and do your quizzes and all that kind of stuff on a regular basis. Follow along with me. If you guys are sleeping in class, sleep at home, right? Don't sleep here, sorry. Unless, of course, you're texting all night or on the phone, and then sleeping is okay, right? If you want to eat in class, like let's say you want to bring a coffee or whatever, I leave it to your discretion. I would recommend that you keep it close. Don't spill it on the computer in front of you. That would be bad, right? Because then I'll be in trouble, right? But if you want to bring a coffee in the class, I'm not going to say no, okay? Just from a norm's perspective. Okay, so we talked about methods, object-oriented programming, just as a review, and what they are. We're going to be talking about classes, objects, encapsulation, inheritance, all these kind of funny words, not next week, but the week after. And I think this is, again, probably the key that you need to learn from programming 2, okay? Object-oriented programming a little bit. If you don't know how to do this stuff, like I said, then I've missed my mark on what you should be learning largely from this particular course. Okay, and what a class and object is. We have a few minutes. Can anyone tell me in their own words, I won't go to you, just don't answer me yet, okay? What a class would be, and again, in their own words. If you're going to define a class, I know I'm going to leave it up here anyway, but I want you to use your own words. Tell me what a class is in your mind when it comes to object-oriented programming. I know you don't have a lot of experience. Tell me from what you've learned so far. Give me a sense of it. Yes?
Is it a group of similar entities or similar things?
Close. All right. Anyone else? Don't be afraid.
It can contain many methods.
The what?
It can contain many methods.
Many methods. Many methods. Could be, yeah. That's part of it. One of you two guys.
Is it a blueprint?
I like the blueprint idea, right? I kind of set it up there anyway. So let's think about this blueprint thing. So if we have a class, right, and I'm talking about this way ahead of time, but I'm going to create a blueprint for myself. It's almost like a mini program. That's how I look at it, right? A class is almost like a mini little program that I'm running within my program, right? When I create a class, it doesn't do anything until I invoke it. I like to think of it almost, I don't know, I'm a gamer, so I'm almost thinking about it like, the class is like a demon, right? It resides somewhere in the deepest pits of another dimension, right? And when I summon up this class, I'm instantiating it into an object. I create this class. If you're a Star Trek guy or some kind of sci-fi guy, I press the button, all of a sudden it goes, and it appears, right? The object I'm talking about from the class. But I need the blueprint. If I had a blueprint for a human being, and the human being was a class, right? It would have, all human beings have eyes. Well, most of them do, right? And most human beings have arms and legs and a head, right? So I would need the blueprint if I was going to make a human being out of scratch, if I was a necromancer or something crazy like that, right? And I press the button, right? My blueprint for my human would be, the class, right? My object would be the human himself or herself, right? But there could be different kinds of humans. There could be male humans and female humans, right? Just from there alone. They have different properties, right? So the blueprint is there to give us flexibility to reuse the methods and properties that are related. I like what you were saying about related methods and properties, right? Inside of a class. And when I instantiate this class and create an object, right? The object can be reused over and over again. Example of this would be if I made an enemy alien in a game, right? The alien is going to come at you and try and fire at you. So the alien is going to have some kind of properties. Maybe the alien is going to have speed, so he can run around, right? And he also might have methods to make him turn, like turn right, turn left. That might be 2 methods that he has inside the class, right? I can invoke those methods by saying something like, if my alien was called alien, small a, as opposed to alien, capital A for the class, so my alien, alien1, right? If I said alien1 dot turn left, I would be invoking the method to turn my alien to the left, right? If this class and object existed. Similarly, in a more simpler example, which I put here on the PowerPoint slide, if I have, let's say, an automobile, and this comes right from your book, right? It has attributes like a make, a model, a year, a purchase price, and all that kind of stuff. It also has some other attributes like speed, gas level, tire pressure, all this other stuff. These are all attributes, right, for your car, right? Now, the class is the blueprint for all cars, right? Every car has these things, pretty much: a make, a model, year, a purchase price. Maybe you purchased it for 0, but that's still a purchase price, right? Someone gave it to you. Speed, maybe the speed is 0 if it's parked, right? A gas level, it could be full of gas or out of gas. It could be different. It could be positioned in different from a gallon perspective. How many gallons of gas, right? And tire pressure, how much pressure is there? And maybe there's more than one tire. How many tires do I have? It could be a tire array, right? As part of my properties, right? These are all things that the class defines and are containers, right? They're containers that are inside the class that I'm going to be accessing. It's almost like an enum. Remember, if you guys did the enum last semester as well, that kind of show different members of the enumeration, right? It's the same kind of idea. You've got a bunch of properties that are inside the class that I can access, right? It's kind of a precursor here. And then I have methods, right? Like the method, the car can drive, right? I can drive the car forward and I can go back. I can turn left and I can turn right. These are all methods to drive the car, right? I can turn the radio on and off. Hey, wait, the radio might be a class of its own, right? Because if anything, I could call a class within a class, right? And we'll talk about that a little bit. That's where we get a little bit confusing for some people. But at the end of the day, we're creating this blueprint and we're instantiating it. I want you to have that in your head as we move into the next couple weeks. My blueprint, here's my blueprint. It shows me all the stuff that's in the class. And when I instantiate it, I'm like the hand of God. Poof, I create it. I got the object and I can recreate all these objects over and over again. 10 objects. Each of them are going to have their own properties and they're going to use the same methods, but they're based off one blueprint. So I can have different instances of the same class, and that's what the objects are. Okay? So again, very, very high level, what we just talked about. But we're going to go back into details and how do we plot this out? How do we use the pseudocode to make it go? What my expectations are for that, and how do we instantiate that class? I think so from lesson 1, and I'm just going to run through it a little bit more. It talks more about polymorphism and so on. But really, within the first lessons, I mean, we really want to talk about Microsoft Visual Studio, which we've talked about, how it's similar to Java and so on. But really around C#, what's the difference between C# and C? We talked about that already, and using the system namespace. That was like, I think would be lesson 1. Lesson 2, right? Really quickly as an overview, you would have learned things like variable names, how to declare variables, difference between variable data types. How about in JavaScript? Who's done work in JavaScript before? So if you're a web programmer, do they have data types in JavaScript? Huh? Not really. How about in Python? Do they have data types in Python? They have data types in Python? Well, JavaScript is really loosely typed, right? So there is a data type in JavaScript. Actually, there's a couple. But they're almost like inferred as opposed to explicit, right? They're not strict like they are here in C#, right? And the data type for JavaScript is any. That means they could use any data, any variable you declare can do anything. It can be a Boolean, it could be a string, it could be an integer, it could be a float, it could do any of those kind of things. Not so here in C#, right? C#, all the variable names are case sensitive, right? That means if I use lower camel case or upper camel case, Pascal case, 2 different kinds of names, right? But it's really confusing when I have a class name, which we're going to talk about in the future. I define something like alien, right? And I make my object alien with a lowercase a. That's bad, right? We do it all the time, though, as programmers because it's easy for us in our head, right? But the right thing for us to do is make something called maybe more of a generic class, like enemy. That would probably be a better class name, right? And maybe my subclass would be alien, a type of enemy, right? And we'll talk about subclasses later on, right? Or let's say, for example, it's automobile for those people who are on the software side who hate games, if you're not a gamer, right? But automobile is really kind of really high level, right? Maybe the superclass or the first class before automobile would maybe be vehicle. It's not just generally, it could be a vehicle with no tires, right? Maybe it's got treads. Maybe it's got horses, right? That would be kind of the higher level vehicle. And then your automobile would be your subclass, right? So we don't want to create the same name, lowercase, like using the lowercase variable name as the uppercase class. We want to use something else and something that makes sense. So if I have an enemy class, I may want to call it, and if I'm playing a Star Trek game, as an example, I may want to call my instances Klingons. That makes more sense. Klingon is an instance of the enemy class in the Star Trek game, if you're playing Star Trek, right? I'm just saying, right? And if you're a Star Wars fan, and by the way, Star Wars is coming out in 2015 again, right? By the way, when I was a kid in 1977, I'm an old guy, right? Star Wars, I saw it in a theater, right? So so they're coming out with it again. Star Wars had enemies and allies too. They had the Rebel Alliance, right? And they had the Evil Empire, right? So the Evil Empire would be a type of enemy, empire. Allies would be rebels. And you can make an ally class or an enemy class, but you wouldn't use enemy with a lowercase e and ally with a lowercase a to describe your variable. Please don't do that. That's where I'm going with it. So we talked about variable names in lesson 2. I'm not going to go too much deeper than that. And the type of data types and how to convert from one type of data type to another. That was really important as well. Chapter 3 was excluded because you guys didn't do any GUI work at all, right? So and it'll be probably something that I will include in along with when we start doing UI stuff towards the end of this course, right? So you guys didn't do Chapter 3, right? Chapter 3 is all stuff to do with Windows Forms. So that means that you don't need console anymore, right? Which, you know what, we want you to get away from console stuff, and you'll get more of that when you go into Programming 3. You start building more UI stuff, right? User interfaces. So you didn't do that. Chapter 4, we talked about decisions, right? And we used if-else and switches, right? What's the funky thing about switches in C# that's different than in other languages? Do you guys remember? If I use switch, some of my structure, and I'm talking components now for building the building blocks for what we do, right? And I'm gonna see if I can just kind of skip down here. There's some pseudocode and some diagrams here. If I've got my if-else statement, if-else, 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 I got a lot of if-elses. That's cool. But if I'm testing a particular case, right, this is where switches can become more much easier. I don't want to say if my enemy my enemy X is in this coordinate, or my enemy Y is in this coordinate. I want to say switch enemy X, and if it's one of these cases, then this is what's going to happen. And the thing with switches in other languages is they have something called fall through, right? There's no fall through in C#. That means there's no default. You have to define every single case. I'm just trying to find it here. And of course, I probably won't be able to find it. But in the switches, if else, if else. Yeah, I can't do it here. What was that? Was that there? Yeah, enumerations. But from a switch perspective, the switch statement itself, logical and or operators, what it allows you to do, and of course I can't find it because it's not necessary, it replaces the if-else statements over and over again. So if I go into let's go on the on this side, if I start creating a statement, first of all, in order for me to use a statement, I have to create a variable, right? So let's say in my main method here, I'm going to create a variable. It's going to be of type int. And I'm going to call it, pay, right? And let's say I define my pay as 30. So I've, pay is a value of 30. It's an integer. Hey, it kind of gives me that squiggly line. How come it says the squiggly line is there? Well, if you look at the IntelliSense, it says the green squiggly line is there because I've never used pay as part of my in my code at all, right? Well, once I start switching stuff, if I say switch, I use the switch statement, and I go and I need to put something that I'm going to switch in there, pay, which is my property, my local property. I also got to put in a code block, and code blocks, remember how they work here. Code blocks are signified by an opening and closing brace, right? These are all the code blocks. That's what I'm going to refer to them as, right? Code blocks, right? So you have a code block for the switch statement. You can also have code blocks for if statements, and so on. But inside a switch statement, you're going to have a case. So if I say case, and if I put a value, I'm going to put a literal, like let's say, for example, 10 with a colon. That's typically how we do it. And then I use a break statement, right? Is that correct? This looks like it's not giving me an error. Well, if the value is 10, then I want to use my console.writeLine, right? Not window height. Console.window height. Console.writeLine to kind of output that it's 10, right? Right? It's 10. That would be an option. But in other languages, what you can do when I say fall through is do something like this. Case 11. And then I go something like case 12. And so, oops, I can't do this properly. Case 12. And case 13. And then break. Can't do that here in C#. It won't work. It'll error out. You can't do this kind of work. You've got to do each individual case, and there's no fall through. So it won't fall through case 11, 12, and 13 to do the stuff in here. In JavaScript, it will. And some other languages, it will. But please don't look at this as something that will work here in C#. It will not work. Okay, you can't do this. Speaking of which, another kind of building block, if you will, was of course the main one, which is the if statement. So if I go if, pay is equal to 30, this might be not the right thing to do. Could I do this? Could I do console.writeLine? It's 30. Right? Could I do that? Should I do it? That's the other question. Come on, Smarty. What do you think? Should I do this? Should I write my code like this? If pay is equal to 30, why? You're shaking your head. Tell me now. I want to see yours. No, you shake your head. I saw you shake your head. Tell me what. What was that? I need the code block. Why do I need the code block? It's absolutely correct. Why do I need the code block? Anyone? Okay, Smarty, tell me why do I need the code block.
So it we can easily identify, we can easily distinguish, and if there are more than one line, then it won't execute like this.
Correct. If I add another line here, if I forget to, this is perfectly fine, by the way, from a syntax perspective. It will not give me a syntax error. However, it could cause logic errors, because if I sit there and go, I also want to do a console, I'm going to kind of tag it in here, console.writeLine, yay, or yeah, right? Well, yeah, print out. Well, look, it even spaces it out for you differently, right? If pay is equal to 30, console.writeLine is 30 will work, right? But this console.writeLine, yeah, will not work, right?
It will always be shown as an output, no matter whether pay is equal to 30 or not.
It won't. It will always show, right? And the reason why it always shows, we think in our mind that I want to add in another piece of code. And if you're from a Python perspective, you're thinking, hey, if I just tab in, because Python doesn't use curly braces, right? If I just do this, that should be sufficient. And some people might write it like this, especially if you write it in a code editor or a text editor, as opposed to Visual Studio 2013, 2012, right? So if you write it in a code editor, this won't error out. There's no syntax error here, but there's a logic error. So it's better always to use curly braces. And if we do that, of course, what we want to do is put all both these commands, I'm just going to drag and drop them, inside of my code block. Okay? So this is the right way to write an if statement. And the same thing goes with an else if. If I start writing else, I want to write that code block. I want to put that code block in there right away. And you should kind of get into the habit of putting your code block in as soon as you put in your conditional. Here's my conditional statement. Here's my code block, my braces. Now I'll put my code inside. Okay. I know you guys are glazing out, so we're going to stop in a second. Bear with me a few more minutes. So that was what we did in lesson 4 of last semester. Let's go to lesson 5 really quickly. A little bit of looping. These are like really, in my opinion, I would say these are like the building blocks of all coding. If you haven't done looping, if you haven't done if statements, all that kind of stuff, well, then you're really in trouble as a programmer, right? You don't know what you're doing, right? So you need to understand these basic structures. Okay, so when is a good time to use a while loop? Why would I use a while loop as opposed to a for loop? Come on, Smarty, I know you're going to answer me. Go ahead.
When we don't know the number of iterations to perform.
I don't know the number of iterations. If I don't know the number of iterations to perform, I can use a while loop, and I can use a sentinel variable outside the while loop to initialize it, right? An example of that would be pay is equal to 30, like we did last time. So if I go here back to Visual Studio 2013, I know that pay is equal to 30 up here, right? But let's make something else like instead of pay is equal to 30, I'll leave pay is equal to 30 in there, and I'll create another variable that I'll make it a bool type variable, and it'll be keep going. I'll call it keep going, right? And I'll set it up to true, right? Oops, if I can actually type. True. So keep going is equal to true. I've initialized it as true, right? And I'm just going to kill this right now because I don't need this. But let's say, for example, I have a while loop, right? And if I say while keep going, I could do it that way. I could also make it is equal to true. Is equal to true, right? I could do this too. I'm going to ask you questions around this in a second. Then, right, while keep going is equal to true, pay plus plus. I want to increment the pay value, right? And then what I want to say is if pay is greater than or equal to 50, right? Then inside my if statement, I'm going to say keep going, right, is equal to false. Is this correct? Would this work okay? So what do you read here? So what we've got here, again, basic looping structure is while keep going is equal to true, I'm incrementing my pay variable, and this is where your comments would come in, right? So if I was writing code for somebody else, not myself, I come in here and go increment pay, right? And then maybe another comment would be something like check if pay is 50, right? So I've got a couple of comments in there, right? Check if pay is 50, increment pay, and then check if pay 50. And if it's true, if it's equal, then we're going to change our sentinel variable, which is our keep going. We're going to change to false, so we can exit the loop, right? That's a while loop. That's a good iteration for a while loop. Is there another way I could write the condition, though, while keep going is equal to true? Do I have to write it like that? How can I write it?
You can just say while.
While keep going? Can I do that?
Yeah. Because by default,
By default, it's going to check to see the condition of the, because remember, the variable itself, keep going is an object. Even though it's a property, it's also an object. And it's going to be equal to or equivalent to true. So this is also correct, while keep going. You might see this format online a lot. If you actually go check out online how they code, you'll see this a lot more than while keep going is equal to true. What about if I do this? While not keep going. Is this okay? While not keep going. It's okay, it's just ugly, right? It's like false. If it's not keep going, right, that means if it's not true, then you do this. Now this would run forever, right? If it's not, actually it would skip over it the first time and it would never run because in the beginning I've initialized my sentinel variable. Here's my sentinel variable, and I'll put that in there, right? If I want to, at the top of my class, I'm going to say this is the sentinel variable. When I say sentinel variable, it's an old school term to kind of define, hey, I need to define something before I create my while loop, almost like a precondition before I enter my while loop. I got to create this condition so that way my while loop will run or not run, right? If this is true, then this will never run because it's going to check to see if it's not true, not keep going. It's a very ugly way of writing it, right? And probably the better way to write it would be to check if it's true. That's always the better way to write it. So always check for a positive if you can from a coding style perspective because not keep going is ugly. Although you could say is equal to false, right? You could say that as well. And I prefer keep going is equal to false as opposed to not keep going in many ways. However, if you were going to write not keep going, as long as you kind of justify why, if it makes sense from a coding perspective, you could use that. So while keep going is equal to false. But here, in this particular case, this would run fine. While keep going, right? Increment pay, my pay is going to be kind of go up. And then at the end, I want to do something with that. So maybe what I want to do is I want to do kind of a console dot write line, and then maybe kind of print out pay, right? I want to show what my pay is. Okay? So I want to be able to do that. Maybe use some interpolation to kind of add that in with a little bit of string or some kind of a string text along with that. Because right now it's just going to output a number, which is kind of ugly as well. So if I run it, will it actually execute? Look how I've got my lines. I've got right line hello world, I've got a space, I've got press any key, and then I got this read key. If I'm running this method, and if it's in the main method, shouldn't I move this somewhere else? Well, the answer would be yes. If I want to probably do it somewhere down here like this, right? Otherwise, we'll never see pay because it'll flash in and out, right? This way we'll see it. From an order of operations perspective, it's going to define pay as 30. It's going to define the sentinel variable as true. It's going to increment it until it's 50, and our output should be 50 from a command line perspective. All right, so let's try that out. If I press, and if you notice it says 50, it's hard to see up here, but it does say 50. But what I'll do is next time is I'll increase the font size of my console so it's really big and ugly so you guys can all see it, right? But it's 50. And if I press spacebar, it's gone. So my little code worked, right? A while statement. So that's a good use for a while. For statement is when we know the iteration amount. I know how many, right? How about a do loop? When would I use a do loop? I want the output at least once, right? I'll tell you right now, in a lot of my coding, I never use do loops. Do loops are deadly. D for deadly, right? Because it messes you up, right? It always runs at least once. Most likely in most of my code, I always use, or most often use, while loops or for loops, right? That's most often what I use when I code. Not that there's not a space for do loops, but it's a special condition, a special case, if you will, right?
Can be used for menu-driven program.
For what?
Menu-driven program.
For
We are displaying a menu to display.
a menu? A menu is okay if you want to display it for the first time, right? But that's from a console perspective, it works okay. But if you're making it so that you want to use a menu on in a UI, you know, that's where it becomes useless again, right? So there's not that many cases. Usually, when in a UI, a user interface, menus are run different ways, and you don't need to use those anymore. But you're right. In that particular case, you want it at least to run once, so that the person's inside the menu loop. That's what you're doing there. Okay, and you can have nested loops because you want things to run. Kind of, let's say if you want to iterate across a row and a column, if you're using arrays, then you might have a nested loop situation where you're running between those two things. I'm going to stop there because that's enough. I know some of you are glazing over and everything else. Please, what I'd ask you to do is for next week, this is kind of the end of the review for, kind of last semester, and I kind of ran through it pretty quickly. I wanted to hit kind of the highlights. But for next week, if you have the book, I want you to read Chapter 8. Go through Chapter 8. Some of the questions I put up on the poll already. And next week, I should be able to give you your first assignment. That's when you're going to be given it, right? And then it'll be due, I believe, by week 4 or something like that, right? So further down the line, a couple weeks after. So please be prepared. If you read ahead, you'll get more out of this. And again, I'll try and record our stuff as we go. Okay? Otherwise, that's it for me.